Assalamu alaikum wa rahmatullah. My name is Sujad Dosiri, Mechanical Engineering student, Community College of Qatar. This video is a project video for Applied Fluid Mechanics given by Dr. Faisal Faiz Alayan. Today in this video I'm going to try to design and run CFD simulation using SolidWorks software of a vertical axis wind turbine. And to do so, you need to click File New, or here click New, choose Part, and you want to start by choosing a plane to draw on. You can choose top plane or front plane or right plane depending on your application. So I'm going to just click top plane, click here Sketch, or just click up here Sketch. We're going to start by drawing a circle because the general design of our vertical wind turbine is circle base. So click from here, just size it anything, just click and just size it whatever you like. Just click here because you can size it later, and to do so you can size it from here from the bottom, or you can do smart dimension, and I recommend doing smart dimension. It's a good practice to smart dimension everything. What this does is define a dimension that will be set by the software and saved always, meaning if you pull apart or later if you drag the mouse here and there, this will never change because you smart dimension it, you locked it in the system. It will only change if you actually went and click on it and change it, otherwise it'll be locked and saved in the system. For this, the units are millimeter. You can change it to whatever units you like, but I'm going to keep it at millimeters. I'll delete. I'll just write. I'll make 1,000. Okay, it's the diameter of the circle. Now it's dimensioned. Now just click. Just to make sure it's millimeters, double click. Yep, it's the millimeters. Okay, just click OK. Now we have the circle drawn. We need to go now to features. If you exit sketch, this will hide, and this is what you have. Okay, so you can still keep sketch or off, doesn't matter really. Now we go to a feature called extrude base. This arrow shows you the direction where the extrusion is going to happen, and this is the height of the extrusion, or you can call it the thickness, depends on you how you look at it. Increase it from here or decrease it. I'm just going to keep it at 10 millimeters. Here you choose the direction, blind or offset from the surface, or up to body, or mid-plane. Mid-plane is meaning the plane we draw on, it will expand from both sides. I'm going to demonstrate it now. See? So I just kind of keep it blind. Okay. Just click OK. It's also a good practice to define a material. So the material is not defined, so you can just click Edit Material, and you can see here there's a lot of materials. Here you can see iron, aluminum, copper, titanium, plastic, other metals. There's also wood and rubber and silicon, and all of them have these property displayed here down. So you can see elasticity model, yield stress, density. So you choose the material you like. Okay, for your wind turbine. I am going to choose, just for the sake of it, copper. I'm gonna choose brass. If you just, I'm gonna move here. If you click apply, see how the color change. See? So now click close. Now whatever we're building, it's going to be from the same material. You can change it later, define it later, each part by itself, but it's a good thing to do it from the beginning, because whatever you're building, it's going to be in the same material. So now we're going to start by building, drawing the blades. the blades, so you need to sketch. This is the original sketch without the extrusion, but we don't need that. We actually need to draw on the face itself. Okay, so I'm just gonna click here, normal to. This will flip it to my side, the original side. You can see. If you click, now this is facing you. Click on the face itself. Don't click sketch, just click on the face. Now you see it shows this face, not the bottom, just the top. Okay, normal to. Okay, so we chose this face. Now if we click sketch, it will sketch on this face. And I'm gonna click a circle, choose the middle. Okay, choose the middle, and first circle, draw it to the end, 500. Second circle, draw this. We need this to define the width of our blade, meaning the smaller the circle, the more wide our blades in width. So I'm just going to keep it around 370 or 375. I just click here and just go down here and just define it 375. Okay, now 375 millimeters, this is the size. Okay, you can smart dimension those as well if you like. Okay, so if you click here, we'll dimension it as 750. Okay, and here as well it will define this is the same. Yeah, this will help you if you're trying to make drawings from this later. If you're trying to build it actually and you want to print a paper. Click OK. Now we have it defined. Now we need to still draw in this phase, and we need something called a spline. Why do we need a spline? Because a spline is easy to draw and manipulate. Start from here and click in the, try to click in the middle anywhere. You can change this later as well. I'll show you how. Okay, now to exit the spline, once you're done, just click escape. Make sure everything is connecting to all the lines, because this is very important. Now see where we clicked. Whenever you clicked, so if you move, we'll create a curvature. So it depends on how curved you want your blade to be. Right now we can curve it this way. We can run simulation and run it again to a different curvature and see which one fits to your project. Click OK, and now we go to features. I'm putting this to the side just to show you a better view. Extrude, and we click here on the line to extrude it. But see, it's a bit thick, so if you want to change the thickness, go to thin feature. Do not unclick this, just keep it. Here is 10, let's make it 5 millimeters. See, became thinner. And here we define the height. Make sure you untick merge results. I'm going to show you how now. I'm going to keep it, going to give it a height of 1000 as well, or give it a height of 1050, whatever you like. So you can, this is a preview, you still didn't create the part. You can see how height it is. If you want to shorten it a little bit, you can do so by reducing the height. I'm just going to keep it at, but I need to untick this. Why? Because if I don't untick this, whatever I'm extruding, it will join with this and it'll become one part. To become one part. This will make it hard for me to manipulate the drawings later, or to actually create the part and copy and paste it anywhere, or like duplicate it. So unmerge, you can merge them later as one part later in the setting if you want to. Now we click this. See, now we have the part. drawn here. It's also good to since this is a blade and it's interacting with the wind, it's also good to make it round a little bit, and to do so you choose a feature called fillet and click this edge and this edge. But because the radius is a bit large, it will give us an error, so you need to change the radius, because it treats a fillet or a corner to smooth it. It's like a circle, so you need to reduce it so it will be logical. Let's see 2 millimeters and see how it goes. Alright, there we go. Here, let's see, increase it to 3 millimeters. Try to get as much result as we can. Oh, this is better. So just click OK, or you can just, while you're doing it, just go to the other side and click here and click here and click OK. The reason we're doing this now is because we're duplicating this part, so we need to make it as best as we can, then we duplicate it. Okay, now since this is a circle and this is a part, you can copy and paste and try to adjust it, but it will be a very hard process, because you want to align all the blades at even distance in this circle. So we're going to use a feature called linear pattern, but we click on the arrow, make sure we choose circular pattern and click bodies. See, because we didn't merge this, we can choose it by its own. If we didn't untick the merger, if we click, it will choose the whole thing, because this one and this one, the base, are merged together. But now, because since it's not merged, we can choose it by itself. Now choose equal spacing 360 and the number of blades. Okay, I'm gonna see if we can get no, actually choose the fillet. We don't want the fillet, we want the part itself. Okay, oh sorry, clear selection, gonna choose here. Okay, and yeah, click OK. Okay, select sketch. Alright, okay, I got it. We need to go here, actually, not here, and just choose this. Okay, choose bodies. Okay, click here. We are facing a problem, just let me figure it out. I need to choose this part because we need to be circled around something. You can increase the number and decrease it as much as you like. Here's 10. This is a preview, meaning it's not created yet, so choose blades that fits to your project. I'm gonna keep it at even 10. Okay, it's a bit slow. Okay, now 10, and click OK. Okay, and now click OK. Voila, see, it's created at the same height, at even distance of each other. What we want now is the final step of completing our turbine, is to draw the top plate. And to do so, to make sure you're doing correctly, just go to the face here, the top of any blade, and just click sketch, click circle. Why? Because we want to make sure that the circle we're drawing actually touching all the surfaces of the blades, and since they are in the same height, choosing one will be sufficient. Okay, just put it any size and size it as before. Okay, 500. Okay, and click OK. Same thing. There are actually many ways to do this. You can extrude, copy this and put it here or something, but this is much easier, much more convenient. And extrude. It's going to extrude this to a very long height, because last time we actually chose this feature was when we chose the height of the blades or the height of the turbine, plus or minus 10 millimeters. Okay, there we go. Now click OK. We did merge this with those. You can unmerge them. Okay. Now we are done with our wind turbine. Okay, this is the final product. Click Save and save it where you desire. I'm going to save it in this file and just call it VWAT, vertical axis wind turbine. Okay, click Save, and now we go to File, New, and for this we're gonna just draw a tunnel, a test tunnel. This is, we're gonna need it to conduct our flow simulation. Choose top plane, right plane, whatever you desire. I'm just gonna keep on top plane, since I started drawing on top plane in the first place. For this we're gonna choose rectangle, but I'm gonna choose center rectangle, so I know I drew it from the center, and it's a very convenient side. I'm actually gonna click undo, and sorry, center, and now okay, just any shape, because you still can smart dimension it. I'm gonna smart dimension it a little bigger than our turbine, because we're gonna place our turbine here. So I'm just gonna make it 1250 millimeters. Okay, same here for this side, or the bottom, doesn't really matter. Okay, 1250 millimeters. Okay, now it's fully defined. Go back to features, click extrude, and for this we are going to choose mid plane and make it, let's just make it 1300 millimeters. Okay, now we have this box. Click OK. We've got a feature called, because we want to make a tunnel, we go to the feature called shell, choose here and flip it, and choose here 10 millimeters. That will be the thickness of the walls of the tunnel. You can increase it to 20, whatever you like. I'm going to make it 20. Okay, click OK, and now we have the spot. Okay, now after we created shell, we need to save it, because we're going to join these two parts together, and then I'm just going to call it wind tunnel. Click save, and now you can close all of them because you already saved them, and start anew, but this time do not choose part, choose assembly, because you can assemble those two parts together. It's taking time a little bit, but be patient. Now it is opening. Okay, see how it's already located the two files. Just click open, choose them and click open. Just click anywhere, just place it anywhere, and the tunnel itself, you can place it anywhere. Okay, and now just to align these two parts, you need to choose a feature in the SolidWorks called Mate. Choose the inside of the box with the service and just click OK. It's supposed to be Mate, but what you need is go to Advanced, Center Profile, okay, and click OK. Okay, so make sure that you click OK. Now we edit the feature. Okay, now because we chose this phase with this phase, and go to Advanced, click Center. How it see how it did? It actually took it to the center of this phase. Now you click OK. You can make it a little bit further if you like. This. Okay, because of the axis we're having, it's actually going the other way around. You can flip dimension and see now if you increase, it will actually keep a gap between the face and the bottom of the plate of the turbine, but it's gonna still stay in its place. Okay, now we click OK. Now after we click OK in Mate, now it's saved. Before it was not saved. Okay, now we can click here just to make sure it's facing us, but it's the other way around. Okay, 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 now okay, this is how we want it. Now click here. Now see, there we go. We now have a full view. Notice how this is made with this as one solid piece. Okay, and now we are ready to do our simulation. We need to save it, then give it any name you like. I'm just going to create it as ASIM, which means it's short for assembly 1, and just click save. And now to go to simulation, you go to this tab here, or if you don't have it, you go to tools or search here and click flow simulation, and you can add the add-ons. Click flow simulation, you need to go to wizard. Okay, project 1 or project, I'm gonna call it project wind. Click, choose the units. I'm just gonna keep it as SI units because it is widely used, and very favored to many. Now for this we need to choose internal, and the reason for that, I know it's a wind turbine, it's supposed to be external, but because we are creating a tunnel, so we are studying the inside, so we're going to keep the flow that we're going to study as internal. Choose rotation, you can choose gravity and other things, but I'm just going to keep it at rotation. Click next, choose the fluid because it's a wind turbine, it's going to be air. Click add, laminar and turbulent, keep it this way. Humidity you can add it or not, depends on what you're trying to achieve. Click next, see the parameters, everything is okay. Click next, and now we're almost ready. But now it says because we're doing a tunnel, you need to create something called lid, and by itself it's warning you to create a lid because of the inlet and the outlet. Click here and click this phase. Let's zoom in. Okay, click here. It's the first lid and the second lid. Choose here. Now it's sealed. Something I forgot to do, click yes, and also to click yes before we start, because I need to actually go back here and click leave the wind turbine. We need the tunnel. I'm just going to click you have two options, either hide or change transparency. You can choose this, see how it became a bit transverse, but I'm just gonna actually hide it much better. Okay, hide component, see, now it's hide. Okay, I'm just gonna normal 2. Okay, and see how the wind turbine is now facing us. Choose this. Okay, see the axis? This is very important. Now go back to the simulation project. Click on this is our project wind. This is the computational domain. Choose it, it's already defined. You can pull this way a little bit further because all the computation is going to happen in this domain. Now since we already define our domain, the main domain, computational domain, now we choose fluid submergent. Okay, just sorry, I mean boundary condition, insert boundary condition, and for the first boundary condition we need to select, there is inlet mass flow, inlet mass flux, but for this we need inlet velocity because we are studying wind and velocity is very important. Choose this face from the inside, mind the arrow of the axis, let's go in the same direction. Okay, that's good. Keep this reference axis as X and click OK, and we are done with our first boundary. Make sure, see how the arrows, so if you're spectacle, because these are a bit closer to each other and it's very difficult to see the study you're running, you can always go back to the original drawing and just you can edit it. Okay, for this I'm just gonna go here and just gonna go okay, just 1 second. Okay, because I was hiding the part, that's why I couldn't edit it, but just click here, unhide, and then you'll find this toggle, edit part. It will take you to the original part. Just click the arrow here, it will show you where you did your first extrude, and just edit this feature. Okay, we'll make it 2000, or you might make it 3000. Oh, that's a good length. That's a good length for our study. Click OK, and now click here on the edit component. Now it's good. We've already done everything we need. Oh, sorry. Go back. Don't forget to hide it. It's not that we don't need it. We need it, but we need to hide it to see the study. But we need to change now the lids, because we already changed the wind tunnel. After deleting the previous lids, and now we need to create new lids, so we go to Tools, Create Lids, and click this face and this face. Click the two faces and just click OK. And now we go back to lids. Just click yes, because it needs to compute again now, since you are creating new parts to your assembly. And go to the wind tunnel. I'm gonna hide it. And now we are ready to insert our boundaries and then run our studies. Okay, for this we're gonna click here, insert boundaries, right click, and choose the inside of the lid, and choose inlet velocity, because we're gonna study the speed of the wind. Try to make it let's say 5 meters per second. Okay, click OK. See the arrows here. Okay, you can edit this if you like. Just click edit definition. It will take you back to this window. You can choose spiral or 3D vectors, normal to phase, and many things you need to you can manipulate. Okay, full of developed flow. Okay, that's actually better. Click yes. And for the second boundary, we need pressure. For this you need to click this tab here, environment pressure. We need the environment pressure. Just keep it like that. Click yes. And now we are ready to run the simulation, run the study. Click run. It will just take you to this, and click run. Another window will appear. Click here. You can see how the solver solve the equations. You need to solve all this and until it reaches convergence. So just give me a second. Okay, now the solver is finished. Okay, close it or keep it in the background, depends. Now you have results. You have it before, it was empty. Now you have actual result in it. You want to see how the flow interacts with your turbine, and this is very important. Okay, I'm going to try to make it align to our side, and just leave it on an angle a little bit. Okay, Now we'll make this 200. Okay. Flat arrows, fine lines. No, make it lines with arrows, or lines. Just lines are better. And make it say 300 lines. Okay. And for pressure, no, actually keep it just this way, and it will show you the lines of the sorry, need to select the phase. Yeah, select here and just click OK. Okay, these are very thick lines. We need to edit them. Where is it? Flow trajectories. Click edit definition. Okay. Okay. And planes and mesh lines. Okay, this is 10. Now we need to make it 2. Alright, let's see. Oh, that's better. That's very better. Okay. Also, you can go play and see how it hits and change. Okay. Another way to do so is the definition, because we are defining this is the pressure. Okay. You can now see the velocity, because we are also interested in velocity. See how velocity change of the air after it hits your model. Okay. Now we are going to also play around with this a little bit. Or you can keep this and insert a new. So if you want to see two things together, okay, let's see here. So actually I'm gonna click this, delete it, and keep this as our pressure. This pressure. Click OK. Alright, see, it's now different drawing. So I'm just gonna can hide this and see how the pressure differs in your model. Okay, or insert, you can delete, you can clone. I'm gonna actually delete this and this and insert new flow trajectory. This time you want to see how the velocity of the wind, or the wind, interacts with your wind turbine. What you want to do is choose the number, make it 300. Okay, we need to be choose it as lines, keep it as lines, just lines. The thickness of the lines, keep it at 2. And now we choose velocity, and after that we need to go and choose the wind turbine itself. Okay, just choose this and click OK. See? Amazing. See how the wind interacts with your blade. See how it curves from the top a little bit and goes around it. See inside how it hits the blade and curve around the blades. There's all sorts of things you can do with the flow simulation in SolidWorks. It's a pretty amazing tool. Thank you very much. I know it's a bit longer video, but hopefully I'm gonna try to improve and make it shorter and shorter. Thank you very much.